Hey students, how are we doing today? So, what? I couldn't hear you. Thank you. Okay. I'm doing well too. Thanks for asking. We're gonna try number 5. I think this is like the second number 5 or the third number 5 in this packet, but this is about the game. It says let's make a bet. You pay $5 to play. I have one 4-sided die and with the numbers 1 through 4, and one 6-sided die with the numbers 1 through 6. We roll both die and record the sum of the two die. I'm paid $8 if the sum is a 3, 6, or 9, and paid $12 if the sum is a 2 or a 10. Kitty, I'm sorry. My cat's all over the place right now. He's right in front of me, messing with all my stuff. Okay, so part A, let's construct the sample space. And with the sample space, we have two die. One has the number 1, 2, 3, 4, 5, and 6. My cat is rubbing his face against my iPad. I'm sure you hear that noise. Now he's playing with my pens and knocking stuff over. The fat black cat's hungry. Even though he got fed twice already, he's like, oh, I had first breakfast, second breakfast, but I still need 14th breakfast. I haven't had that yet today. Alright, so let's construct the sample space of all possible sums. Again, we have one die has the numbers 1 through 6, and the others have the numbers 1 through 4. So we're going to have 2, 3, 4, 5, 6, 7. You start doing these enough, you kind of notice these easy little patterns. You see here, I'm going to start with 4, then it's going to go 5, 6, 7, 8, 9, and then here I'm going to start with 5, and then 6, 7, 8, 9, and 10. So that's the sample space. It's all possible outcomes. For instance, there's only 1 out of 24 possible ways to roll a 2. There's only 2 ways out of 24 to roll a 3. 3 ways out of 24 to roll a 4. Alright, so you're paid $5, you pay $5 to play. You're paid $8 if the sum is a 3, 6, or 9, and you're paid $12 if the sum is a 2 or a 10. So let's find out first, what is the probability that we get, let's say, a 3, 6, or 9? Well, let's go back to our, this is why we want to construct this sample space, 3, 6, or 9. So we look, okay, there's 2 ways to get a 3. There's 4 ways to get a 6, so we're up to 6. And there's 2 ways to get a 9, so we're up to 8. There's 8 out of 24 possible ways to get a 3, 6, or 9. And then let's also find out what the probability that the sum is a 2 or a 10. Well, there's only one way to roll a 2, that's to get 2 ones, and there's only one way to get a 10, and that is to roll a 6 and a 4. So there's 2 out of 24 possible ways. I'm going to, this is going to be 1/12. There's a 1/12 chance of getting a sum of a 2 or a 10. And just to keep the denominators here the same, even though 8 over 24 is 1/3, I'm going to leave this in terms of 12 as well. That there is a, sorry, my cat's looking at me funny, 4 out of 12 ways to get a 3, 6, or 9. So if I add these two together, the probability that I win, I could win both ways. So that's going to be 5/12, 4/12 plus 1/12. So that implies that the probability that I lose, which is really what I'm after here, is going to be 7 out of 12. Since 5 out of 12 ways to win, 7 out of 12 ways to lose. Isn't that right, fat cat? So what I want to do here, actually, before I calculate the expected value, is let's set up a little chart. X is going to equal the amount of profit I make. So I could win, let's see, I'm paid $8 if the sum is a 3, 6, or 9, which really means I'm winning $3 profit, right? And my probability of doing that was 4 out of 12, or I will write it as 1/3 at this point. Or 8 out of 24, write it how you will, it doesn't matter. Let's see, and I'm paid $12, so that's going to be a profit of $7 since I paid $5 to play. I'm going to be, walking away up a cool $7 if I roll a 2 or a 10, and I had a 1/12 chance of doing that. And then I lose. How much do I lose? Well, I pay $5, so I lose negative $5, and my odds of losing were 7 out of 12. So at this point, I want to calculate the expected value. Put this in a pretty little table. Okay, so the expected value is going to be 3 times 1/3. Ooh, that's going to be 1 plus 7/12 plus negative 5 times 7/12. How did I get that? This 7/12? Well, I just did 1 time. I'm sorry, 7 times 1/12. What are you doing, weird cat? I'm glad you can't see this, but he just like put his face in front of mine. It's like he's still hungry. I fed you twice already, fat cat. It's 9 o'clock on a Sunday morning. You've had first breakfast and second breakfast. You can't be that hungry. So after putting that in the calculator, I get negative 1.33. Now, I'm just going to verbally say this, and the question here, part B, really asks for, would you play this game? And I guess it was an ambiguous question. I forgot to mention, how would you know to play this game? Well, this is what you want to do. You want to calculate the expected value. In this case, the expected value is negative. That means I would not play this game. I would not play this game because in the long run, I would lose $1.33 on average every time I played. Now I just want to reiterate that there's no way if I play this game only one time that I can lose $1.33. If I played it once, I would either come up $3 up, $7 up, or $5 down. But if I played this, let's say 100 times, and then at the end of the 100 times, I took how much money I had or lost and divided that by 100 by the amount of times I played, I'd find an average amount of money that I would have made per play. Chances are that's going to be about negative $1.33. Of course, everybody's going to be different. Everyone's going to get different luck, but on average, you would be losing $1.33 each time you play. So would I play this? No way. Alright, part C here, which skipped a couple pages because I had some printing issues, said that, okay, let's do another game here, same idea with the 2 die, but you're going to get $4, you're going to win $4, you're going to be up $4 if the sum is prime. Well, it's a fair price to play. Well, Mr. Bessling's a little cruel. Had you remember what a prime number is? A prime number is any number 2 or more that's divisible by only 1 or itself. It's not divisible by any other number. The first couple prime numbers are 2, 3, 5, and 7. And then if you want to keep going, it'd be 11, 13, 17, 19, 23, 29, and we'll leave it there because our sums only go up to 10, so I just need the first, the prime numbers less than 10, so it's 2, 3, 5, and 7. So I want to go back now, and let's find out what the probability that we roll a prime number is, as my cat is playing with all my pens and all my paper. Dude, will you... Alright, so 2, here's 2, 3, so there's 3 ways total. Here are all the 5s. What are we up to here? We were at 3, 4, 5, 6, 7, 8, 9, 10, 11. I got 11 ways to roll a prime number out of 24 possible ways. So my probability of rolling a prime number with these 2 die, one 4-sided, one 6-sided, is 11 out of 24, almost 50-50, a little under 50%. So that should give us an idea that a fair price to pay should be a little under $4, since it's just a little under 50% to win. But let's find out. So when something is a fair price to play with one of these games, then the expected value over the long run is 0. That is, you're going to win as much as you're going to lose in the long run. Well, let's see here. So we could either win, and we win if we win, we're going to win $4, and the probability of us winning is 11 out of 24. Now we're going to lose. We don't know how much money we're going to lose yet, so I'm going to call that Y. I'm not going to call it X just because I don't want, it's not the same X as we have down there to the left. And if my odds of winning are 11 out of 24, my odds of losing are 13 out of 24, the complement, right? So let's calculate, well, we're going to calculate this expected value, but we're going to set it equal to 0. Why are we going to set it equal to 0? Well, that was up here. So that's going to be 4 times 11 over 24 plus, it's going to look cool if I write it in red, y, now I have to switch back to green, y times 13 over 24. I'm going to subtract the 4 times 11 is 44. I'm going to subtract that 44 on the other side, so I got negative 44 over 24 is going to equal 13 over 24 times, so we got here in red, we got y here. I guess it doesn't need to be in another color at this point. Both denominators are over 24, so I can cancel that. I get negative 44 equals 13y. Divide each side by 13, and y is going to equal negative 44 over 13, which, let me put in my calculator here. Negative 44 divided by 13, and that's negative 3.38. So that would be a fair price to play. $3.38. That's how much you would lose, and you would win $4. And then if you kept playing this over and over at that price, eventually, or over the long run, not necessarily eventually, but if you kept playing this over and over and over until the cows come home, you're not going to be up any money, you're not going to be down any money. Hope that helps.